Okay, good morning again, everyone. Welcome back to Intro to Speech Understanding. So last time I showed you that if you go to the Jay Hasegawa Intro Speech Understanding GitHub, you can look in 2025 Spring Lecture 1 Notebook, and that will show you how to create your own GitHub account, how to fork the code repository into your own GitHub account, how to install GitHub Desktop in order to download a copy of the code to your own machine, and then how to clone, edit, commit, and push on your own machine. So I'm going to go now to the account that's in the version of this code that I forked into my student account. Let's see. So this is um, let me find my own repositories as a student. Here we are. Here's I created for myself an account as if I'm a student and created in that account an introduction to speech understanding. And in that account, let me go to lecture 2 and see what we have in lecture 2. So for the next 3 weeks or so, I'm going to be introducing Python to you. First, we'll spend a couple of weeks just introducing the Python programming language. And then after that, we'll spend a couple of weeks introducing NumPy and Matplotlib. And then after that, we'll actually get into speech understanding. So if you already know Python, the next 2 weeks will be very easy for you. The next 3 weeks probably. And if you don't already know Python, but if you know some other programming language like C++ or Java, then you should find that Python I think it's easier than either C++ or Java. It has some interesting concepts that don't exist in C++ and Java, but the syntax is much more forgiving. So it's usually much easier to program in Python than it is in other languages. So the first thing I want you to do is to actually install Python on your computer. We're going to be following, for the most part, the material from this textbook called Make Python Talk. So this is a textbook that you can buy if you want to. I'm going to be following the material from that textbook for the first part of this course and for the very last part of this course. But you don't need the textbook. You can understand this course entirely based on these lecture notes that are available on the GitHub site. So if you just download the lecture notes from the GitHub site, then that will contain everything that you need. So in particular, we want to be able to install Python. And so probably the first thing that you want to do is to go to is to install a version of Python. And if you don't have Python already installed, I recommend strongly the Anaconda system. So Anaconda is this programming environment. It has this green circle as their logo, and you can create an account and sign in, and then just download a copy, or you can just go to Get Started and download a copy. Let's see. Do we have? Oh, here we go. Free download. So you can just download a copy of Anaconda for free. Enter your email address and agree to receive communications, and then you can download a copy. And once you've done that, then the software becomes available to you. And then you can do things like you can run many things from the Anaconda desktop. From the Anaconda it looks like I've uninstalled the Anaconda desktop, but it will install things like it will install things like the command line Python and like Jupyter Notebook. So in particular, let me go back to the course webpage for today. Once you've installed Anaconda, then the one reason to install Anaconda is that it will automatically install many packages that we need, like NumPy for numerical arrays and Matplotlib in order to do plotting and things like that. And in particular, it will install Jupyter. So Jupyter is the way in which web pages like this web page become runnable Python code. This one is running on a server on GitHub, but we can also run it locally on my own machine. So the way that I usually do this is by opening a command prompt. And if you've never opened a command prompt, here's instructions. If your computer is running Windows, then you can use this instruction in order to open a command prompt in Windows. If you're running a Macintosh, then you can use these instructions. And if you're running Linux, you can use these instructions. And in on Macintosh, it really is so as simple as typing in terminal and then opening a terminal, and it should look like this, right? So you should be able to open up a terminal. Let's see, there's a question in the chat. If you have PyCharm, so try the following. Try going to the directory where you have your local copy. So in my case, it's documents, and then let's see, GitHub, and then intro speech understanding. And then let's try Jupyter Notebook. Let me increase the font size, right? So you can see what I've done is I've gone to the documents directory, and then I've gone to the GitHub directory, and then I've changed into the directory called intro speech understanding. And then this is the key command, Jupyter Notebook. If you have a terminal open and you type Jupyter Notebook and hit return, then it should open up a Jupyter Notebook on your screen. And if that works, then your Python installation is sufficient. If that doesn't work, then you might want to try installing Anaconda. So if you go to a terminal and type Jupyter space notebook and hit return, then you should get something that looks like this. If you don't, if it issues an error, then you probably should try installing Anaconda. So here I'm going to just navigate down to lecture 2. And in a Jupyter notebook, if I open up an IPyNB file like this, then this becomes runnable code. There are basically two kinds of windows in a Jupyter notebook. There are windows like this that are called Markdown windows. And Markdown is just a text formatting language. So as you can see, if I put a hashtag at the beginning of this line, then it turns that into a heading. This one has 3 hashtags at the beginning, which turns it into a subheading. This one has numbers and it has links, for example. These are all different kinds of document markdown that we can create inside the Jupyter notebook. So here's information on Jupyter. You can go to docs.jupyter.org in order to find the latest information about running Jupyter. And here's information about Markdown. Markdown windows contain text, which is formatted using Jupyter Markdown. And here's a guide on the Medium programming site that shows you information about Markdown. I'm not going to sign into that right now, though. You don't actually need to know anything else about Markdown for this class. You don't need to be able to write your own Markdown. You just need to know that all of this formatted text, it's formatted using special commands like this. 2 asterisks means boldface. A back quote like this means that it should be formatted in the way that you can see here, shift return, right? It's formatted as a computer command. And links are formatted if you just enter an https:// then Markdown will format it as a link like this that can be clickable. Those things are not really very important to us. What we care about are the code windows. So this window, you can see if I click on this window, it says Markdown here. If I click on this window, it says code. And that can be changed. I can change it to Markdown or I can change it back to code. But the advantage of code is that it will run Python live. So if I change this to contain the text print hello world, and then hit run, this triangle, right? Then it runs that command. It runs print hello world as a Python command. So anything I put into this window will get run automatically. If I want to print 4 + 5, then it will print 9. And I can print 4 × 5, and it will print 20, which is 4 × 5. And so this is extremely useful for learning about Python, right? If you want to learn how to program in Python, probably the easiest way is to just put commands into this window and run them. If you just put 4 + 5, for example, it will just return the value 5. But notice if you just put 4 + 5 and then 4 × 5, the only one of those that will print out is the second of them. Notice that the 9 in response to this 4 + 5 no longer prints. If you want to make sure that each of those is actually printed at the end, you need to put a print statement around it, like this. So we put print statements around those, and then it prints out all of those 920, 920, and we can continue playing around and learning more about how Python works by just experimenting in the code window. So Jupyter is extremely useful in this way. Essentially, the idea of, and you can see the Jupyter logo in the upper left corner here. The idea of using Jupyter is it allows us to learn about Python in something that looks just like a web browser window. So it becomes much easier to use. So the key idea is that we want to be able to write Python in Jupyter. But let's go back to this window here. We have homework2.py and grade.py. This says import my first script. If I run this window, it will say no module named my first script found. And this is because the import command is a special command that brings code in and tries to run all of that code. And so in order to create that code, I need to create a file called myfirstscript.py, right? So in order to write Python in Jupyter, one thing you can do is write code directly into the code window. The other thing you can do is create a new file. The way that you do that, this is important, choose a new text file, and it will come up called untitled.txt, and then you have to change its name to something.py. That will tell your operating system that the file is a Python file. So let me create a new file here, new text file. And it has to be actually a new text file because if you call it a Python file, it will become a Jupyter notebook. So let me change the name of this one to myfirstscript.py. And now let me put in this print hello world. And now let me choose file, save that Python file. Now I have a file called myfirstscript.py. If I go to the directory listing, let me reopen this directory listing, renew this directory listing. You can see that it now contains myfirstscript.py. And so if I go back to the lecture 2 notebook, now if I import my first script, you'll see that it imports all of the code from my first script and runs it as a Python program. And the result is that it prints out the statement, hello world. Right? So now we have two ways that we can write Python code in Jupyter. One is that we can write it directly into the code window like this. The other is we can write it into a separate Python script, and we can run that Python script from anywhere. The only trick is that if I import my first script again, the code doesn't run a second time. If you want to rerun a script that you've already run, you have to use the import lib. So import lib is a special command where you can type import lib reload my first script, and it will run again all of the code that existed in that file, my first script. Right? The other thing that's interesting about this is that now that we have it in a Python file, if you go to the shell, right, the terminal window is just running whatever the terminal program is in your operating system. So let me go to Documents, GitHub. Let's see. Intro speech understanding. And let's see, let's go to 2025 spring. And let's go to lecture 2. Now we have my first script. You can type more my first script.py, and it will show you the contents of my first script. You can also run it. We can type Python my first script.py, and it will run my first script.py as a program, just on its own. This doesn't work for the Jupyter notebooks. If I try to do Python lecture 2 notebook.ipynb, that won't work. It'll give me some kind of error, right? So the Python interpreter on the command line doesn't know what to do with Jupyter, but if you write it as a separate Python file like this, then the program called Python will know what to do with it. And so you can run Python my first script as often as you want, and that code will run. And in this way, you can create code that you can run inside the Jupyter Notebook, but also outside the Jupyter Notebook. You can also run this code from any other source. You can run it in Spyder or on the command line or in any other programming environment that you like. All right, let's go back to the notebook. So now that we know how to create a Python program called my first script, and now we know how to import it and how to import it again so that it runs the second time. Now let me go on to start teaching you about Python. Are there any questions so far? I've gone through very quickly sort of how to install Python and how to use Jupyter Notebooks. This is kind of a lot of material to begin with. Are there any questions about this so far? How many of you have used Python before? Nobody has used Python before? Ah, in that case, maybe it would be a good idea, try, how many of you have used a terminal before? Yes, okay, good. Um, yeah, please do install Python on your computer and try running this Jupyter Notebook and make sure that you're able to run this Jupyter Notebook because this will become important for understanding the code as we go further into the course. All right, let me assume that you know how to use Jupyter and that you'll be able to use Jupyter. And let me go ahead and continue to talk about how to program in Python. So it's worthwhile. It's a very good idea in general to learn a little bit about how to program in Python. So let me just introduce the Python tutorial. There are lots of good Python tutorials on the web, but the best one by far is the one at python.org. So if you go to python.org/3/tutorial, then it gives you a tutorial introduction. The first section is called Whetting Your Appetite. The second section is called Using the Python Interpreter. And then the third section is an informal introduction to Python. And it's well worth, if you've never used Python before, I strongly recommend that you go to docs.python.org/3/tutorial in order to follow the tutorial to learn the basics of how to use Python. Let me just put that up for a moment again. I'm going to introduce some of the basic concepts that you can also see in that tutorial. So for example, in order to code in Python, one thing you can do is just put a comment into your file. If we go back to my first script, we can enter a comment like this. Something like this is a Python program. This line is a comment. The interpreter ignores it. I can put these three comment lines and save it. And once I've saved it, if I go back to the Jupyter Notebook and rerun it, import lib.reload my first script, you can see that it prints out hello world, and that's all. It doesn't generate any additional information. All it does is generate generate the hello world. That's one way to generate a comment. However, a much more useful way to generate a comment is something called a docstring. And a docstring is any string that you put at the beginning of a script file. So if I go in here and put quote, this is a docstring, end quote, and save it, I put this string at the beginning of the program. What is it going to do with that string? If I go back here and reload my first script, it doesn't actually print out that string. All it prints is hello world. But now if I ask for help, then it will print my first script. This is a docstring. So the text that I put into that string at the beginning of the file goes here, right? And so you can ask for help on your own programs. And this is especially useful if you use this syntax where we put 3 quotation marks in a row and then end it with 3 quotation marks in a row. Then we can make a multi-line string. Having 3 quotation marks in a row makes it a multi-line string. So I can say this is a doc string. It describes the content of a program. This program is just an example script. All it does is print the words hello world. The end. And then I can add an extra new line in order to add a little bit of blank space. Now I have this great multi-line string that might contain a lot of information about the contents of this program that I've written. Now, if I go back here and reload my first script, all it does is prints out the word hello world. But if I ask for help about my first script, then it will give me this entire information. This is a doc string. It describes the content of a program. The program is just an example script. All it does is print the world's hello world. So all of this text that I have highlighted in blue here, all of that text is from the string that I put at the beginning of my program. Right, so you use 3 quotation marks in a row that allows you to define a multi-line string. And in that multi-line string, put any information that you want the users of your program to see when they type the word help. Right, they type the word help and then the name of the program, and it gives them all of that information from the doc string. That same syntax can be used to find help on any built-in Python function. For example, the word print. We can get information on the command print by typing help print. And it tells us, here's help on the built-in function print in the module called built-ins. This function print takes a series of arguments, and it prints all of those values to a stream or to system standard output. So the separator is a string inserted between values. The end is a string appended after the last value. The file is a file-like object to which it should print its content. And so in this way, you can use help to find out about existing programs, or you can use a doc string in order to generate help for your own programs. All right, the tutorial recommends starting out with arithmetic in Python. One of the great ways of using Python is you can just use it as a desktop calculator. So for example, if I want to know what 7 times 123 is, I can just run this code and find out that it's 861. If I want to find out what 7 times 101 is, I can run this code and find out that it's 707. Right? If I want 7 times 50, I can run this code again and find out that that's 350, and so on. We can add that information. We can do all of those same things inside my first script, but we have to wrap them up in print commands in order to make sure that they get run. So if I print 5 plus 6, print 9 minus 4, print 9/3, print 5 to the power of 3, print 13 modulo 5, print 13 integer division 5. Let me add a string to the beginning of each of these. Remember that print takes a series of arguments and it prints out that series of arguments. And so the first argument in each of these is going to be the string, and the second will be the arithmetic operation that results from applying that operation. So now I've got 5 plus 6, 9 minus 4, 9 divided by 3, 5 to the power of 3, 13 modulo 5, and 13 integer division 5. Let me save this. And then let me go back here and rerun my first script. And you see the output, 5 plus 6 is 11, 9 minus 4 is 5, 9 divided by 3 is 3.0, 5 raised to the power of 3 is 125, 13 modulo 5 is 3. So this percent operator in Python means take the remainder after integer division. 13 integer divided by 5 is 2. So 13 divided by 5 is 2 with a remainder of 3. This is what these last two lines mean. The last line is integer division. The second to last line is the modulo operator. So these are different arithmetic operations that you can do easily in Python, and you can just use it as a desktop calculator. If you want to find out how many days there are in 14 years, you can say 14 times 365 and return, and it's 5,110 days, not including leap year. All right, so that's the first useful use of Python. Just use it as a desktop calculator to perform your arithmetic. For any more advanced uses, of course, we need to define variables and values. So a variable is an internal register somewhere in the programming language with a name. So this first variable is going to be called name1, and I'm going to put into it the value kcgi. And this value is a string, right? A string is just a sequence of characters inside quotation marks. Name1 equals kcgi, name2 equals Kyoto. So I can just run this code, and now I can print out what is the content of name1, and it will print kcgi. What is the content of name2? If I run this, it will print Kyoto, right? We can also find out its type by saying, what is the type of name1? And we find out that its type is this special value called class string. So it's a particular kind of class, that is a particular kind of object. And the particular kind of object that this is an str object. With strings, actually, operations like plus and times and divide have special meaning. The plus symbol in strings concatenates two strings. The times symbol repeats a string. So I have the string Kyoto, and I'm going to repeat it 3 times. And so when I run this function, I get kcgi is in Kyoto, Kyoto, Kyoto. So we have name1 is in name2 times 3, right? So here's name2 times 3. I've just repeated that string 3 times in a row. So we've been working with strings a lot. Here you see something new. You see that you can concatenate strings with plus, and you can repeat strings with a times operator. Let's look at numbers. There are 2 types of numbers that matter in Python: floating point numbers and integers. And these are distinct because only integers can be used to index an array. But most arithmetic operations require a floating point number. So there's 2 different kinds. Floating point numbers can be expressed using decimals, like 17.89, or they can be expressed using fractions. If you express it using a fraction, then the fraction will be evaluated in real time as you enter it, and it will evaluate to a decimal number. So 5/3 evaluates to 1.6666667, right? So we get these 2 different values, x and y, that have the values minus 17.89 and 1.66667. The type of each of these 2 variables is floating point number. So they're both class of float. And one of the things we can do with a floating point number is round it off to the nearest integer. So if I round off the value 1.667, the nearest integer is 2. If I want to take just the next lower part, then I can ask for the integer value. If I take the integer value of y, that's 1, right? So take 1.667 and drop off the fractional part, then I get a 1. But if I want the nearest integer, then I want to type round, because I want to round it off to the nearest integer, and that's 2. And a floating point number can also be converted into a string. So I can take the string of 17.89. What that will do is that will create the string 17.89. So let's type print the class of 17.89 is, and then class 17.89. And then let's say the class of string 17.89 is class of string 17.89. And then we'll print 17.89 times 5 is, and we'll print the value of 17.89 times 5. And we'll take the string of 17.89 and multiply it by 5. And we discover that those generate very different things. It looks like I've got a syntax error somehow. Oh, I need one more parenthesis. Oh, type, not class type. There we go. The class of 17.89 is float because it's a floating point number. But if I convert it to a string explicitly using the str operator, it becomes a string. If I multiply the floating point number by 5, I get 89.45. But if I multiply the string times 5, then I get the characters 17.89 repeated 5 times in a row. So we get different kinds of operations depending on whether we're multiplying 5 times a string or 5 times a floating point number. Right, the other type of number that we need to know about are integers. And the key difference between integers and floating point numbers is that there is no fractional part, right? An integer is just the number 7 or the number 23 or the number 0. If I define all of those integers, then we see that they all have class integer, which is different from class float. If you divide two integers, you get a floating point number. So the division of minus 23 over 7 is minus 3.2857, which is of type class float. If you just want to get the integer division, then you do this double division. This 2 slashes in a row gives you the integer part of a division. So if minus 23 divided by 7, the integer part of that is minus 4, which is the next integer lower than minus 3.28, right? If you convert a floating point number to integer explicitly, so we take minus 17.89 and convert it to an integer, then it will just truncate the fractional part. So minus 17.89 converted to integer is just minus 17. 5/3 converted to integer is just 1. The fourth fundamental type of variable is a Boolean. So we have strings, floating point numbers, integers. A Boolean can only take 2 values, right? It's either 0 or 1, true or false. So the first, and the Booleans are the result of operations like 4 is greater than 5. 4 is either greater than 5 or not greater than 5. In this case, 4 is not greater than 5, and so the output of that operation is the value false. So the first Boolean will have the value false. The second Boolean will have the value true because 10 is in fact greater than or equal to 6. So if we run this, we get that 4 greater than 5, that statement is false. But 10 greater than or equal to 6, that statement is true. So we have 2 Boolean outputs. The first one says, yes, 4 is not greater than 5, so that's false. The second one says, yes, 10 is greater than 6, and so that statement is true. This class is different from the classes of integers and floating point numbers. It's called a bool, B-O-O-L. It stands for Boolean, which is the name of binary arithmetic. Boolean variables can be converted to other types. So we can convert the word true to an integer, and the result is the value 1. We can convert a 1 back to Boolean. The result is the value true. We can convert the word true to floating point. The result is the value 1.0. We can convert 1.0 to Boolean. The result is the value true. If we convert false to an integer or a floating point number, the result is the value 0. And if we convert 0 back to a Boolean, the result is the value false. So basically 0 is false and 1 is true, but they're not, except they have different types, right? 0 is either an integer or floating point, and Boolean is true and false are Booleans. A Boolean has to be always either true or false. If we take the word true and convert it to a string, it actually becomes the letters TRUE. This is just sort of, if you want the string as a result of true, then it's just the value TRUE. Similarly, we could take the string false we could take the value false and convert it to a string, and the result is the string FALSE. So it didn't really make sense. Nothing else really makes sense. And so the way that the designers of Python created this is they just set it up so that if you convert a Boolean to a string, you get the name of that particular Boolean value. The last thing I should tell you about variables is sort of what are the rules for variable names. So a variable name can't start with a number, right? A variable name can be anything that cannot start with a number. So it can end with a number, or a number can be inside it. You can have the variable name can be called bit 8, but the variable name cannot be just called 8-bit. And you can't use divide or plus or times or anything else as part of a variable name because that would be confusing. The only special character you can use as part of a variable name is the underscore. And the underscore makes it possible to define very long names that contain the concatenation of many different names. And then finally, these words in the KW list cannot be used as part of as your variable names. So you can create a variable name which is false 5 or false 6, but you can't create a variable name which is just false. If I said something like false equals 5, if I run this, we get an error. I can't take the word 5, I can't take the word false and treat that as if it was a variable. But if I say false 5, now it's some other string. Now I'm allowed to use that as a variable. And so I can print out its value in this way. False 5 is 5. So this particular sequence of names, false, none, true, and, as, assert, async, await, etc. All of these are the words that cannot be used as variable names by themselves, but if you add a number or an underscore after them, they can still be used as variable names. All right, that's all we need for week 2. I just wanted to sort of introduce you to this idea of Python variables. So the homework this week is in homework2.py, and it will be lots and lots of different variables. Let's go and take a look at it. If we open up the file homework2.py, we see that it has a whole lot of variables here. And basically, we need to redefine all of those variables. We want variable A should have a string in it. It should be the string, this is a Python string. So let me go and define that. Variable A should be, this is a Python string. Variable B should contain the integer that results after you execute 7 modulo 3. Probably the easiest way is to just say B is equal to 7 modulo 3. Right? Let's see, let's take a look. Variable C should contain the integer that results after you execute 55 times 234. So let's go back here and let's just enter 55 times 234. And that should generate the right integer. Variable D should contain the string that results after you execute name1 plus at plus name2, where name1 is KCGI and name2 is Kyoto. So if we go back to homework 1, we see that name1 is none, so we'd better change it to KCGI. And name2 is none, so we better change it to Kyoto. And then variable D should be equal to name1 concatenated with at, with 2 spaces around, a space on either side of it, plus name2. Let's see, is that correct? Variable D should be name1 plus space at space plus name2. Good. By the way, we can use single quotation marks or double quotation marks, whichever you like to define a string. It should be the same one at the beginning as at the end of the string. Variable E should contain the floating point number that results after you execute round of 3.458 to the nearest 2 digits. This is kind of interesting. In Python, the rounding function isn't only used to round something off to the nearest integer. It can also be used to round something off to the nearest floating point number. So when I round something off to round a number off to a certain number of digits, then it rounds it off to number of digits precision. So if I'm going to round off 3.458 to the nearest two digits, then it should round off to 3.46. That should be the nearest floating point number. So let's enter that, round 3.458 to the nearest two digits. Variable f. Variable f should be the string that results when I convert the integer 57 into a string. So let's go ahead and just do that. We'll convert the integer 57 into a string. Variable g should contain the Boolean that results by asking whether or not 5 is equal to 9. So this Boolean will just be the Boolean false, but we can put that over here, 5 equals 9. And it will, just to make sure, let me put that in parentheses so that it evaluates. It'll evaluate 5 equals 9. That will generate the Boolean value false, and then g will contain the Boolean value false. Variable h should contain the string that results by converting minus 23.0 into a string. Variable I should contain the floating point number that results by converting the Boolean value false into floating point. So we'll convert the Boolean value false into floating point. Variable j should contain the Boolean that results from Boolean quote Python unquote. Interesting thing, any string other than the string false will get converted to the value true. So if I convert the string Python into a Boolean, it will actually get converted to the value true. And then finally, look at the following 5 strings: global, toPrint, print2, underscore SQU, and list. Variable k should be a string containing the concatenation of only the ones that are valid variable names. So let's see. 2PIRNT starts with an integer, so this can't be a valid variable name. The others might be valid variable names as long as they're not things that are listed in the global keywords list. So let's see, is global listed? Global is in the global keywords list. So we're not allowed to use, this is not a valid variable name because it's in the global keyword list. This is not a valid variable name because it starts with a digit. Print2, let's check to see if that's in the keywords list. NOP, no, print2 is not in the keywords list, so this is a valid variable name. So let me add that to variable k. And then I want to add that to anything else in here that's a valid variable name. Underscore SQU. There are nothing in the global keyword list that includes underscore SQU. So underscore SQU must be a valid variable name. And this one is a little bit tricky. I think list, is that included in the list is not included here in the keywords, but list is actually a type. So I think that list may not be allowed. Let's test it. Let me go ahead and leave it with just print2 plus SQU, and then I'll save this file. And then let me go ahead and check it by running grade.py. There's another program here, grade.py, that if you open it, you can see how I'm actually grading. I'm going to assert that homework 2 variable A has a particular type, has the type equal to, this is a Python string, and that the value of homework 2 dot A is equal to the variable A in grade.py. So this assert asserts that homework 2 dot A is of the right type, and this assert equal checks to see whether the values are equal. And you can see that there are a whole series here, and test k is, yes, it's actually checking to see that that k is equal to print2 plus underscore SQU. So we can actually, if you want to, you can check in grade.py to see what the expected values are. Let's run that by typing !Python in order to run grade.py. And it ran 11 tests and they were all okay. Another way that you can actually run this is by typing import grade, and then it will run the same code, run 11 tests and got positive results. All right, now that we've created the homework, we've got the homework working here and it works in our notebook. Now you have to, once you've done that, then you need to show me that you've done that. And the way that you can show me that you've done that is to use GitHub Desktop to commit and push your repository. So remember, if we go to GitHub Desktop, that's not what I want. Let me find the GitHub Desktop program. Oh, that's odd. GitHub Desktop is not showing up. I wonder if I need to, oh, here it is, GitHub Desktop. So if I open up GitHub Desktop, it should show me the changes that I've just made, and I should be able to use GitHub Desktop in order to commit and push those changes. So you can see that it's showing me that I've changed from A, B, C, D, E, F all being none to A means this is a Python string, B is 7 modulo 3, C is 55 times 234, and so on. So I can just create a summary saying I finished homework 2, and then this is just the changes that finish homework 2. I can commit that to the repository, meaning I'm done with it. I want it to be confirmed. And now I can push it, meaning I can send it back to github.com online. Now that you've done that, you should be able to go to your own GitHub site. So if you go to github.com and then log into your own repository, log into 2025 Spring, Lecture 2, homework.py, you should see that the homework has been changed so that it includes all of these values. If I go back a couple of steps, if you go to my original repository, you'll see the original value of that where it was not yet changed. If I go to lecture 2, homework2.py, the original value has none of those changes, but in the version that you created for yourself, it should have all of those changes. So if I go to J. Hasegawa student, 2025 spring, lecture 2, homework2.py, it has all of these changes. I can also go to lecture 2 notebook.ipynb, and I can see that on GitHub, my lecture 2 notebook has the section where I ran grade.py and everything worked is shown in the lecture 2 notebook. So copy the URL for one of those two things. Let me copy here the URL for the homework, and then go to homework 2 and just copy into homework 2 the URL for your copy of homework2.py. So go here and copy in the URL of your homework, and then I can give you points for that. By the way, if you have not yet done homework 1, please go back and do homework 1 as well. You can watch the lecture. It's available on the course YouTube site. So the course YouTube site is listed here. The lecture 1 is available on the YouTube site. You can go and watch it and then do homework 1. And as shown here, the due date is July 31st for all of these homeworks. So make sure to do them all before the end of the semester. This course is graded entirely on homework. So if you do all of the homework and do it all correctly as shown in class, then you'll get 100% of the points for the course. And that's all for this week. Any questions?
What about attendance?
That's right. Thank you. I need to take attendance. Let me go and go back to take attendance. Thank you for reminding me. Let's see. Camp. I always forget where this is. I think it's here. Okay, so please go ahead and register your attendance using this code. Thank you. Would have been 10 people, I think, right?
Hello, Sensei. Good morning.
Yes?
I am not seeing the code. Where is the code?
Oh, I'm sorry. Oh, thank you. I need to share again. Can you see it now? Thanks. I think there are now 2 people who have not yet registered attendance. Oh, now 1 person. If you have not yet registered attendance, please do so. Shamim, have you registered attendance yet? Shamim
Yes,
Hassan?
sir. I have marked my attendance.
Okay. Oh, there I see. Vimant is there. Ayesh is there. Yasita? Yasita is there. Diane is there. Asai is there. Lisan is there. Choson. Choson, I think, is not there. Choson, have you registered attendance? Choson? All right. Disappearing in 18 seconds. 15, 14, 13, 12, 11, 10. Okay, thank you, everyone. Please complete the homework and I'll see you again next week. Thank you. Have a good week.
Thank you, sir. Bye-bye.
Bye-bye.
Thank you, Sensei.
Yes, yes, yes.